thanks for making it here. Very excited to host one of our leading customers, Nitin Shingate. He's been the CTO of GoodRx now. How many years?
3 years.
3 years. Exciting times. How long has the company been public?
Almost public is 5 years. The company is there for last 14 years.
Awesome. So I'll start with some introductions. We're going to basically talk today about the story of how Skyflow solves certain problems with analytics and LLMs. And then Nitin is going to talk about how GoodRx ended up using Databricks and what they use Skyflow in conjunction with for that and how this came to be. So just by way of background, actually I heard of GoodRx about 5 or 6 years ago when my mom from India was visiting us. She forgot to bring her insulin medication. And I'm insured, thankfully. Skyflow has good insurance in case anybody wants a job. But turns out if somebody is visiting you from India and they don't have an insurance plan, every shot of insulin costs like $1,000. And so I go there and it's going to be 20 shots for the next 6 weeks she's here. It's like $20,000-$30,000. And I think it was the pharmacist or I'd seen some ad of GoodRx and I was like, what about GoodRx? And I literally signed up for GoodRx while I was there. And the price fell from like $1,000 a shot to like $150 or something. And I was like, this is amazing. Like, how come not everybody knows about it? So I actually have a card and I've been using it for many years. And so when we started Skyflow and we're like, hey, what kind of companies should be using Skyflow? GoodRx was sort of our top of mind. So 3-4 years ago, we had reached out, but Nitin's company had already started using a third-party solution to try and make security and privacy work for GoodRx. Obviously, they weren't waiting for us to come around. And so today we'll basically talk about how that changed over the years, what Skyflow does, and how does it work with LLMs and data privacy. So with that in mind, let me give you a quick overview of what Skyflow actually does. So the easiest way to think about Skyflow is there is an architecture pattern that companies with the most amount of sensitive data, billions of rows of data. So everybody here heard of the Equifax data breach and maybe data breach at a certain company that was at Moscone last week with 156 customers, or the Change Healthcare system was down. You look at those stories and you're wondering, okay, these companies have a lot of data, but there are companies like Google and Apple that have orders of magnitude more data. And there's many things you can quibble about with respect to someone like Apple and Google. But one thing they haven't had is a data breach of all of our email addresses ever, right? They've been doing this for 20 years. So what are companies like Apple? Apple just announced their AI. You watched the keynote? So if you notice, the first thing they talk about was how they actually protect the data. Now, in their case, they have the advantage of having a vault-like enclave on the iPhone, but they actually added a compute cloud. They call it the privacy compute cloud, which is very similar to actually what we do in Skyflow, where we offer you a secure enclave where you can do some certain kinds of computations. So the net of all this is leading companies that have the most at stake don't go around buying cybersecurity products from companies that show up at your door. They're not buying layers and layers of firewalls and hoping that no internal bad actor or data breach actor gets access to the most sensitive data. They're fundamentally architecting their data stack differently. So this is, if you remember only one thing from this session, it should be this, that there's a data architecture that's fundamentally more secure rather than buying 15 layers of security after you've created a bad data architecture, right? So think about companies that had the issues last week. Why do they have plain text social security numbers sitting in a data warehouse? Like, have you ever done any computations on social security number? Have you ever multiplied anybody's phone number with an email address? So why are we putting sensitive data in data stores and data warehouses and going forward in large language models? It's because we don't have an easy and clean way to separate these things out. So I don't care which company you work for. You could be United Healthcare, you could be United Airlines, you could be GoodRx. Every company is data stack basically looks like this, right? You're going to have some application that's going to connect to some database. You may have 17 of those. You may have 700 of those if you're Uber. But fundamentally, you have an application database, which then connects to some kind of a historical data warehouse. You may call it a Spark system. You may call it a data warehouse, data lake. And then actually there's one more system that shows up to the right increasingly, which is large language models. But if you think about it, you're going to take all the data in your data warehouse and then all the PDFs and everything else sitting in your data lakes, and you're going to try and build models off of it. And when a phone number or a social security number comes in today, it actually gets copied over again and again, and including going to your logs, goes into your firewalls, goes everywhere. And if you think about cybersecurity industry, we spend about $200 billion a year in cybersecurity. It's gone up by like 3x in the last 15 years. Now, has the number of data breaches gone down? So what is it that we are doing that's fundamentally off? Well, it turns out, anybody here have a small kid? You give them a crayon or ink, and they take the ink and they smear it on your walls. How much harder is it to clean the smear off of your walls versus actually keeping the crayon away from them? In some ways, sensitive data security is the same thing. What we are doing is actually we're taking the social security numbers of our customers, we are smearing them in our log files, data warehouses, our LLMs, and then we are saying, oh my God, this is like really, really bad. I need to go buy 15 products to make sure everywhere I smeared it, I need to protect it so that only the right person at the right time can access it. Well, turns out there's a cleaner way to do this. Whether you use Skyflow's data privacy vault or you use build one yourself, like Google did. If you have 60 engineers, you can build one, and we'll teach you how to. But fundamentally, the idea is that you don't want your sensitive data smeared across your data warehouses, your data lakes, your log files, and your large language models. If you can isolate and protect it, then you can govern it. It's basically taking the crayons, first putting them in the box, and then controlling them rather than managing crayons the once they are all over your wall. So that's what we do. At the heart of all of this is something called polymorphic encryption. This is our secret sauce. So it's very easy to say, take the phone numbers and social security numbers and move them out of data warehouses. Well, what happens when a customer calls? So as Nitin will talk to you about it, when you call up GoodRx, you don't remember your account number. Anybody here know their bank account number? No. So they will ask you for last 4 digits of your social, last 4 digits of your phone number. They'll search for it. The problem is if you've encrypted the data in the traditional way, you can't service those customers. You can't analyze the data. You can't say how many patients in 408 area code got COVID. So historically, there's always been this divide between people who want to protect the data and the people who want to use the data. So your CISO comes in and says, I want a 100% guarantee that nobody has access to this data. And it's like, sure, we'll do that, except marketing needs to run analytics, so we give them 1 copy. Finance team needs to run some numbers, so we give them 1 copy. By the day, large language models, we're going to build some models, we give them 1 copy. You've basically created copies of the most sensitive data over and over again, because there is no other way to give them access in a manner that they can do the jobs. So with polymorphic engine, we are able to do that. And you can learn more about this by going to our site or whatever. And then while we are doing all of this for data warehouses and databases, a new problem has emerged, which is if you're trying to build a large language model, or if you're trying to just talk to a large language model. So this could be a model that you're building. We have a customer called Hippocratic AI. They're building a large language model. It's literally a nurse. They're building a nurse that's going to basically call you up and say, hey, tomorrow you have a scan. Make sure that you don't eat after midnight, all the things that doctors do. When you leave the doctor's office, they're going to call you up, and in a very nice tone of voice, you're going to say, hey, remember to take this medication. All of that, to build those models, they can't use synthetic data. How many people here have been told just use synthetic data? And then you realize, like, how do I create synthetic data that actually manages my customers' real use? If I created synthetic data about People having bank accounts or Comcast customers, they'll all be happy, right? How do you figure out the exact attributes of the data sets? So in reality, it's very hard to use synthetic data. In an ideal world, we want to be able to build these models on the real data without losing the data. And that's what we are able to do with our polymorphic engine sitting between your data source. And when you're building the models using Mosaic ML, or you're building the models using OpenAI or whatever it is, and it's bidirectional. So when the data goes in, some of this information gets tokenized, and when the data comes back, it gets put back in. The key here is you're not redacting the information. The key here is using polymorphic engine, you're going back and forth. So you basically are able to build models on real data and then put that information back in when the answer comes back. So that's basically a 5-minute story of Skyflow. Let's talk about GoodRx. So Nitin, why don't you talk to them about how you learned about us, what was the challenges, just.
Let me give you some background about how GoodRx started using a Skyflow. We used to use a vendor called, I'm not going to name the vendor. We used them for the last 3 years and it was working. The performance wasn't great. And the challenge happened when we negotiated the contract after 3 years and they raised the price 3 times what we were paying it. And we have only a couple of months to decide what to do. As you know, GoodRx is a prescription saving card where you save the money for your prescriptions compared to your insurance price. And we have almost 100 million prescriptions comes or claims comes every year. And that business is growing. So we have a lot of PH and PI information. So we didn't want it to take a risk. So we started building our own tokenization model. And when we scope it out, it was like around 8 engineers and 10 months. We spent around a couple of months. We realized that it's not going to work. So we approached, Skyflow was talking to us and we said, this is the problem. Are you guys really going to do here? And they come into this picture and I can tell you that why we decided to go with Skyflow. Remembering that we have a billions of claims in our data warehouse, in our databases, and how do we save this PHI and PI information? So when Skyflow started working with us, then we realized that we have our existing tokenized data. How can we detokenize and then retokenize with Skyflow? That's going to be a headache. It's not going to happen. We have only 1 month remaining. So what we started thinking about, worked with Skyflow's engineering team, and they allowed us to use our own token, which we already have from previous company, which we used. And Skyflow was able to take out their tokens on top of that. So imagine the tokenized data, we can detokenize wherever we need it. For example, you have username password, which is saved on your browser's cookie. How can we detokenize the data which is with the third-party company, which we are not going to use it going ahead? So we made sure that the backward compatibility of tokenization was critical, and that they really did a good, fantastic job. Second point was, do we have a better access control, especially when we are giving access control to detokenize or redacted data? Can we give access to a specific group of people? We don't want it to give it to every application team. So that was a very critical information or critical capability that helped us to decide that this is a product which is going to use it. And the last one was very critical from the standpoint of we have a distributed databases. And the important thing is how do we manage the tokenization? Can we able to manage the tokenization along with a group? And that was a fantastic feature they developed it, which helped us not to use our previous way of key value pair using API calls for managing our structured databases, structured data sets. So we're using the structured data sets on our own SQL databases and still able to tokenize it and use Skyflow to use the vault technology. That helped us a lot. So I'm going to talk less, but I can tell you, I assure you that last, I think almost 6 to 8 months we are using it, and we are pretty happy. And I think we are going to use it for our LLM models. We are using it with Vertex as well as with The chat GPT, which we have a relations with them for our health content, we're going to use it, and looking forward to see how we can use Skyflow in our all the environments.
What about performance? So one of the questions we always get is, all these technologies, security layers, they have boots. They say it's all going to be seamless, but then instead of a query taking, 30 seconds or 3 seconds, it ends up taking like 10 times as
Yeah,
much
I think
time.
because of you guys have a distributed system, which is helping us that it's not a bottleneck in a single data store where you have to query it. We have a resiliency right now because we have multiple data stores and we can query wherever we need it. So performance is fantastic.
Thank you. So just to re-summarize the points, and we'll take a couple of questions. We have a few minutes. If anybody has questions, raise your hands. So I think you made the points. So billions of patients,
Millions of claims records.
records
Yep.
secured. Only the right teams have the right access, and you obviously have engineers still working on things that my
More
mom
important.
cares about, right?
Yep.
So
Yep.
she's coming back
Totally.
again this summer, and when we need medication, we'll be using a GoodRx card.
Definitely.
And then, you know, we've heard different numbers. You guys had 8 engineers for 10 months. We know Amazon has been having a team of 60 people working on this for many years. We know Uber had a team of 30 engineers working on it for many years. It's just a hard problem because, as I said, it's not about encrypting the data. It's not just about tokenizing the data. It's not just about access control. All of it has to work together. Someone inside your company has to figure out what happens when I rotate the keys. What happens to the backup of the data that was encrypted using the previous keys? Did you make the backup of the keys also? If you did, is that a security risk, or did you keep the old keys in a place where it can't be accessed? So every little thing has to work together for this to be successful. We have a booth over there, booth number 43. Thanks for
Thank
coming
you very
here.
much.
I hope you learned something.
Thanks, sir.